All right, guys, so here we go with differentials. This is the slide titled Example 1. It's really two examples. They follow the same concept, so I'm going to do them both in this particular video. This says find the differential dy. So you remember when we introduced that, we talked about how, there's a minor distinction, but an important one between a derivative and a differential. So just keep in mind that a differential in this case would be called dy. And to me, the thing is, you take your derivative first and then just do an algebraic manipulation to it. So really, it's nothing different than what we've seen before. This should look extremely familiar. So to me, the first step would be to find our derivative dy dx from this thing. As we've done multiple times, we would want to change this into a negative exponent, right? 2x to the negative fifth. Dy dx, derivative, rate of change. All right, power rule on each of these. That should be easy. 15x squared plus 10x to the negative sixth. We can leave a negative exponent there if you want, or pop it back under. That doesn't matter to me terribly. But look, the only thing is, that's called a derivative, right? dy dx equals f prime of x. And to transform it into a differential, I just say treat it like an algebra thing. Solve it for dy. In other words, multiply both sides by dx in order to quote unquote clear the fraction, all right? And so this basically becomes dy equals this quantity. And look, I'm gonna go ahead and put that underneath, right? Negative exponent dx. Now, it would be really important that that be in parentheses to indicate that this entire expression is being multiplied by dx. So once again, please don't leave the parentheses out and then, make Mr. Tsunami have to count it wrong because you left out your parentheses. This is a derivative, this is a differential. This is the rate of change between two variables. This is the amount of change for a particular variable. And we'll have some applications of this on a future example. So really it's the same thing over here. This one, to me, the way you get to a differential is to find your derivative first. And this is really hopefully just review where you would all realize that this particular expression is a product, right on, right? And so we're going to do the product rule in general. I'm short on space here because I know that the frame only goes here, so I'm probably going to work this downward. But to find this derivative, wouldn't it be the first factor times the derivative of this? And there again, this would be chain rule. So wouldn't that be 2 cosine to the first of 8x, taking care of that external power first, and then the derivative of cosine, which is negative sine, and then the derivative of the 8x, which is 8. All right? That's dangerously close to the edge of the frame. I hope you can see that. But basically, that would be the chain rule applied to that expression. Plus, right? And then we'll do the derivative of this one, right? When do I get to be a derivative? All right, so let's see, the external would be cubed, so we start with power rule. By the way, let me label this. This is the first factor, and this all is the derivative of the second one. Plus, now we'll differentiate this one. 3 sine squared 5x takes care of the power, and then the derivative of sine, which is cosine, and then the derivative of the 5x, which is 5. And all that right there again would be the derivative of this. And then this factor already had a turn, so it just carries down as is. The good old product rule. Been there, done that. Okay, so you find your derivative. And then of course the way you transform this derivative into a differential is just like we did on the one over here, whereby clear fraction, basically, right? Multiply both sides by dx. Let's just put a big old grouping symbol around this and put a dx on it, right? I hope you can see this. There's a dx right there. All right, I know that's lazy, but anyway, this cancels the dx, and dy equals that entire quantity in a grouping symbol of some kind. Can you see it? I'm not sure. dx. There's a dx outside those brackets there. All right, I didn't plan ahead real well for space, but I hope that all worked for you. So I appreciate your patience with me. Those are differentials. Big deal, right? Find the derivative and then clear the fraction.
That was easy.
I agree.